Okay, I believe recording has started. So I will take this opportunity to introduce today's speaker, Mark Weiss. He will be speaking to us about his experience with visual differential testing. I've worked with Mark for a number of years now at D2L, and I've seen sort of a version of this talk at our company's internal conference last fall, and seeing that definitely was a factor for me to start encouraging my team to use this type of testing as part of our overall quality strategy. And so I'm excited for Mark to be able to share what he's learned with all of you today as well. So I will now turn it over to Mark. Hang on once I get out of my sharing mode here. So Mark, hopefully you're able to take over the sharing now.
Yep, looks like it. Thank you very much, Tina. And with that, you should now see the first page of my presentation. Let me move over some Zoom controls. Perfect. Okay, so good afternoon, everybody. Thanks for joining us on our first virtual KWSQA online Zoom talk. Today, we'll be delving into the world of visual differential testing. You might ask, what is it? Why should I care? Is it any good? Is it bad? What makes it different from other types of testing? Hopefully, you'll get something useful out of this talk, so let's just jump right in. But let me introduce myself fully. My name is Mark Weiss. I am a senior test developer. I currently work at D2L. I spent a good deal of my career as a tester, but I also did a few rounds as tech support specialist and as a software dev. I did all this after I graduated from UW with a CS degree. So I have a well-rounded career in the tech industry. And today, by popular demand, I'm going to give a talk on visual differential testing. You say popular demand, as Tina mentioned earlier, I gave a talk internally at our conference, and there was enough interest that I was asked to give a modified presentation to a wider audience. So let's start off with the obvious question. What is visual differential testing? So visual differential testing is testing by taking screenshots of your software and comparing them with known good states. So this is used to help catch unintended changes. This type of testing does go by different names. You might call it perceptual diff testing, screenshot testing, image capture testing. But I'm just going to stick to visual diff, which is diff short for differential. But no matter what name it goes by, roughly the same steps are taken in the test workflow. So I'm going to go through these steps so that we're all on the same page when I talk about visual diff testing. So step one, take the screenshot of your application and save it for later. We'll refer to these screenshots as the goldens. These are what you're expecting your software to look like. Step two, wait for some changes to your application to occur. Step three, there we go. Take a screenshot of your application again with all of your new changes. And step four, compare the new screenshot from step three with your golden that you took from step one. Note any differences between the two. And then step five, if there are any changes between them, you have two outcomes. Either the new change in your screenshot is expected, so it's good. Save it as your new golden. If it's unexpected and your golden is still the expected image, you'll have to investigate the cause of the difference. Then step six is go back to step two, wait for more changes, and then repeat the whole process over again. Congratulations, you've completed your first cycle of a visual diff test. So that's all I have for you today. Thank you for coming. And, oh, okay, no, I lied. But you do now have the secret sauce of visual diff testing. So now that you know it exists, technically we could end here. But I'm going to show you my experience with it, what I found good with it, what I found bad with it, and I'll show you the differences it made at D2L. So in the interest of today's agenda, I'm going to cover my journey in implementing a visual diff testing solution. This is going to be based on me using it on D2L's web-based application, but this could be slightly modified to work on a native app or a Windows application or Mac, anything you want. So what I'll cover is why did I actually start visual diff testing? Through that route, specifically, I'll talk about testing in general, large changes. I'm going to talk about my time when I joined a UI-focused team. And then I will quickly talk about web frameworks and web components. Following that, I'm going to show you my solution to using Visual Diff. I'm going to show you some shortcomings that comes with, well, building your own solution. I'm going to show you my solution. And then I'm going to show you the results that came of it to prove that it was worth it. And then I'll provide my final thoughts on the work and where the future lies with Visual Diff testing at my career. And of course, there'll be some time for Q&A at the end, so wait for that Slido link to come back if you missed it from earlier. So you might be happy doing all the testing you do at your regular job, but for me, I was missing something. And what happened? Why did I think I needed to use Visual Diff testing? So can I get a show of hands? Okay, maybe not a show of hands, but who has seen this testing pyramid before? It's this little triangle. Oh, I see Tina, the only one with their camera on, which is fine. So what do I mean when I say testing pyramid? Well, this pyramid here is just a way to help visualize and show the distribution of how many automated tests you should have related to one another. So you should have more unit tests and integration than UI, than manual testing. The closer to the code you are, the more tests there should be, and usually the more stable and easier and faster they are. Now, most of my career as a tester, I focused on the top two layers, the UI and the manual layer. I've written tools and solutions, which I've, unit integration tested as well, to test the UI, as well as scripts to generate data, and then using that extra data to do the manual portion. But where does Visual Diff testing fit in the pyramid? I'd argue it's kind of a tool to assist with the manual testing. And I'll show you why I put it there. So a quick little bit of background about why I needed this type of testing in my life. So as I mentioned, I was a contributor at all levels from tech support development testing. Fortunately enough, at D12, you're encouraged to work on projects that best fit your skill set. They want you to have a successful career and meet your personal goals. In general, you'll land on a team and you'll work on a project and you'll learn the ins and outs. But after a while, maybe it's become dull or you want to explore a new tech stack. It's not uncommon to have people switch teams or do a secondment onto another team. Other times, the teams are built specifically for a project, and once they're done, the entire team's disbanded and they're merged in with others. I was on a finished project team about 3 years ago. It was a specialized project, didn't make sense to keep the team, so we were absorbed into other teams across D2L. I was welcomed into, which is now my current team, which happens to be a UI platform-focused team. I was dumped right into the team as D2L was pushing forward with their UI redesign of their LMS product. The project was dubbed Daylight. The Daylight project consisted of moving to a responsive design, having a clean and consistent look and feel, better accessibility, marketing buzzwords, so on and so forth. I'm not sure how many people in the audience here have used an LMS before. I have. If you're a recent graduate, very possible. If you're a student today, well, it's kind of mandatory. But they can be big. Like D2L's LMS has over 70 plus tools. Redesigning and implementing took years in the making. One team focused on it with all others supporting. You'll see a screenshot there. Is on the left is what it used to look like, and then on the right is the more daylightified version. But to get to that point, there was a lot of checking, a lot of testing, making sure things aligned properly, CSS color changes looked good overall, that design matched. The Daylight experience was officially rolled out shortly after I joined the team, and it was a success. But still, some places were missing some CSS updates because they were missed, or some tools were never fully updated, so those were shored up as they were discovered. But now with the new design to follow, it was key to keep things consistent and stop reinventing the same button 80 different ways. So here's what D2L did to handle that. D2L decided to move forward with creating a public shareable library of custom UI elements. The avenue that was chosen was to create web components. But what are web components? Well, it's a way to create a customizable built-in element that encapsulates everything you need. This means that you won't inadvertently affect other elements and other ones won't affect you, or so we think. Our public GitHub repo can be found under Brightspace UI if you want to go take a look. If you go, do check out our award-winning loading spinner component. Shareable web components were chosen to allow teams to be autonomous and decide which UI framework they wanted to use while maintaining the benefit of being consistent because we're all using the same components. It keeps the look and feel the same, so it's great. So from when I started on the team to now, choosing a web component framework was what we had to do. It's always a tough choice to do this because you're dedicating your work to implementing it in that fashion. So my team was tasked with spiking on different ways of doing it. Eventually, here's how our journey started from my point of view. We started late on Polymer 1. Polymer 1 is just a library for helping to make web components. But after we hit Polymer 1, we found out that there's a Polymer 2. But we couldn't get to Polymer 2 because Polymer 1 actually worked well with IE11, and we had to make sure that IE11 still worked. But then we got into this weird hybrid state. And then from Polymer 1, we discovered that they were deprecating some stuff, so we had to move off of it, but we couldn't go to 2. But then 3 came out, so we went to 3. And then when we landed on 3, we found out that they're not doing any more past 3, like that's the last version. So we eventually made it to 3, and then we jumped off and we found this new one called lit element. And that's where we're at today. But why am I even talking about web component libraries? This is Visual Diff here we're talking about. And that's a good question. But here's a better question for me to ask the audience. How do you test site-wide framework changes of this magnitude? And frequently too. As you saw, we jumped around to a few different versions. All these changes should have zero impact from the end user's perspective. They should not notice any changes. So, seriously, just take a second. I'm just going to be silent here for a few seconds. Think about it. How do you test a library or framework change from behind the scenes? All right, did you think about it? How would you do it? In my situation, I'm dealing with 70+ tools in a web app with different state of the tool, depending on data, permissions, setup, configurations. It's tough. There's a lot to test, to check, really. But let's look at a real-world example here. So you switch a low-level component to a new component framework. Let's say a button. Buttons are used all over your application, like every page has at least a couple. Your unit tests, your integration, and your UI tests all pass. So you get a new testing environment spun up, and it's your job to make sure that the new button works. Well, manually, load up the page, to see that the button switched. Maybe it looks the same. So maybe you have to inspect the code, make sure that the DOM has been changed or that there's new syntax being used. Is that it? Is that testing? Is that making sure the button fixed? It was changed, was working. Should a part of your testing include checking each location where the button's found? Should you have to go through 70+ tools and find every single button and click them? How do you make sure that you've checked every spot if that's the case? And how do you even know where all the buttons are? You could look at the code and see where it's all implemented. Is that worth your time? Is there a better way of all this checking? Well, the example in the top right of the button is an example where the design changed and the border was removed. The buttons across the whole application took the new change and there were no issues except in a select location where they shifted slightly. How do you think we found this one rogue instance? Remember, the unit integration and the UI tests all pass, the buttons still work, but it looks bad. So that's one question, changing frameworks. I've talked about that now. But there are other situations where you might actually have to check a whole site for different changes. Your design team, or if you're not big enough to have a team, your designer devs, whoever makes those decisions, might have a new look and feel they want to be consistent across the site. Or just implementing new components, in our case. You also have an outside requirement that can creep in. So being an LMS company, D2L has to adhere to strict accessibility standards. Most recently, the requirement to be WCAG 2.1 compliant. Of course, there's a plethora of ISO certifications that those to adhere to them, you might impact your whole site. So there's a lot of situations where there's a lot of checking to do. So that's where Visual Diff comes in. So how did I use Visual Diff testing to help fix, maybe not fix, help get by these problems? So with all these site-wide changes, I needed a new strategy to find all these visual defects. Functionally, everything worked, but it was visually, it looked bad. Now, what did I want? So I self-reflected on what I would think would be a good tool. So I came up with the following requirements for a Visual Diff tool. Some of these were flexible, of course, but this is what I was aiming for. I needed something that took a screenshot of my entire application. I wanted to cover all the major tools, lots of pages as possible, different types of data combinations. I needed it to be inexpensive. I didn't have a budget, so open source and free tooling was required. Although I could have asked for a budget with justification, because why not? But I decided not to. I needed it quick like a bunny. I needed it to run as fast as possible. I needed it to be simple, easy to use, and easy to update. That must check my responsive design. The most common screen sizes would be just fine, tablets and mobile devices. I needed multi-browser support because my company, D2L, decides that it needs to be functional in all the major browsers. And of course, this one kind of breaks rule number 3 of being quick, but we'll talk about that a little later. So with my requirements set, I went out and I performed a rudimentary search for a tool that would do everything that I wanted. At first glance, I couldn't find a tool that checked off all my boxes. I did find that some were close, and later on I found more, but by then I already made my decision to go with homegrown. So I cobbled together my years of experience and all my years of testing and automation and tooling, and ended up with the following. Well, I made my own solution, but I did it during one of D2L's famous inspiration sprints. It's a sprint where you get to work on a project of your choosing, and I went ahead and I implemented my solution then. But how did I decide to do it? So because I've had lots of experience in the past with Selenium and C#, I decided to write it in C# Selenium. And why did I do that? Well, my experience, because we already have a lot of code set up for our other automation that I could borrow from, and the multi-browser support with the WebDrivers. For the differentiating portion, actually comparing them, I used an open source library called ImageMagick. It's a command line image comparison tool. It's very neat. You can do image manipulation and other things. And someone actually ported a C# version. So I put that library in my project and I was off. As a freebie, I got a lot of scripts already for my for our Jenkins CDCI pipeline already written up, so that was quick and easy. Oh, and most importantly, it was free. Well, free except for my time, which, I mean, they still paid me, so that's nice. But here's where it all began. Mark 1, the prototype. So I started off small, getting things working locally on my PC. Initially, I had it set up to run and save the images of each run. I didn't have a plan to save the golden comparison images yet. At the time, my current use was to check one of our test sites to toggle between the Polymer 1 and Polymer 3 switchover that I mentioned earlier. Since we had an in-app toggle, it was pretty easy. So turn on 1, take the picture, flip it to 3, take a picture, get a comparison. Everything should have looked the same, but as you can see in my picture there on the left, it didn't. So the differential, as you can see, was a ghosted image where the matching pixels were overlaid over top. If you kind of look in and squint, they're kind of grayed out. Then the unmatched pixels were in red to show what was different. It was pretty obvious, but actually pretty hard to read. So anyways, I got it working in Chrome, as most developers do. It's, browser of choice. Lastly, I designed the test to be quick. So I preset up all the test data on our test sites, and I would So whenever they were deployed, the test sites would automatically have what I needed. Once deployed, my test mantra became this: hit the URL, take the screenshot, compare. I wanted to avoid performing any actions as well as doing anything else on the page, because that would just slow it down. These are not meant to be UI functional tests. These are just meant to take screenshots. Keep things fast, load the website, and that's all you need. So here's some more snippets of examples of the differences I found. You'll see that on the left, there's two pictures. I didn't really like the anti-aliasing of JPEG images, so I had to figure something out with that. Also, I found some constantly changing timestamps, so that was an issue that would have to be resolved. And the red banner there, the one at the bottom that's really red, it was just a new random chosen image that the page gets at random. So I have to figure out a way to deal with that too. So this was a start. Getting things up and running was a good portion of the sprint. It wasn't the entire thing. Like I had a lot of pre-done work, I guess, from all my other projects. And I was also helping other teams with their testing related things during that sprint. So what's next? Time to improve, make it more shiny, Mark II. So the first step I took in Mark II is I removed the ghost underlay from the matching portion of the image. I found it didn't provide much value, and doing so cleaned up a lot of the noise. I updated the color to make it more highlighty. It really pops with that black background, but I think I went a little overboard. I created my first test suite, which attempts to take a screenshot of each tool, and as is tradition, I've dubbed it the smoke suite. My goal was just to hit the tool, take the screenshot, and compare. Remember this mantra, that's what I was aiming for. I also got it working on all the other browsers that I needed, so Chrome, Firefox, and Edge, or as it is now known, Legacy Edge, thanks to Credge or Edgium. I dealt with that pesky anti-aliasing issue by allowing a little bit of fuzz. Turns out ImageMagick library just had a button for it to just call the property and it was done. Lastly, I added a bit of fault tolerance. After a bunch of runs, I noticed that a few pixels would seemingly randomly be different, and it just caused the test to fail. So I'd allow a small amount to be wrong. Turns out that a real defect would actually have hundreds of pixels incorrect. So allowing this fault tolerance in my experience has never masked a real defect. And when I say small, I mean like 20, 30. Here's a few examples of what I found with Mark II. Top left is our nav bar. Turns out that somebody added more padding to it, so everything shifted over. So that was an error that needed to be corrected. The others were mostly environmentally related. Like the bottom one down here is someone changed the global nav bar and added a new tool, or that might have been done via some automation running on the same site. The rightmost square was an error page that the tool got turned off and my user didn't have permission to run and view that page anymore. So things like that can gum up the works. But of course, Mark II, we could do better. I wasn't happy enough yet, but this version was a step up. So then, now we got Mark III. Here's the good stuff. So my Mark III prototype improved on the previous design. I dimmed down the highlighting so that my eyes would stop bleeding. I reused some of the test scripts from my previous UI automation tests and got the visual diff test solution building and running in Jenkins, so don't even have to run it myself anymore. I decided on a new folder structure for keeping my goldens and screenshots. I got it to run every hour on the hour. My smoke suite takes about 50 minutes to run. Takes 250 some odd pictures times 3 formats, so about 750 pictures in 50 minutes. So as I mentioned, saving the screenshots, I decided on this folder structure after I tried many different ones. Not too important, but I started with a base folder called screenshot. Then it goes to the suite name, the code line I built against, I took pictures of, the browser, and then the window sizes. I have 2 Jenkins jobs that run this thing, one that builds it, one that runs the tests. And then the graph down there shows the success rate. They're not 100% green, they're close, and I'll explain why they weren't green a little bit later. And also for kicks in the top right, there's another differential produced by Mark III. So I went through a bunch of prototypes, and this actually spanned a few months. Mark I was done during Inspiration Sprint, but the others weren't. I was encouraged to work on it further and make it better. Why? Because it found bugs, it found defects, actual real defects. That sweet, sweet return on investment was real with this solution. It found things that people didn't know were issues, and it did so quickly. Finding issues quickly while the code is still fresh in developers' minds and before the client gets their hands on it is kind of the goal of what being a tester is. It had proven itself a valuable tool, so much I was implored to give my internal talk on it. But you might be skeptical. You might think, those are just pictures that he made up, and I don't believe him. So here's my actual evidence of some real things we found before they made it out in the wild. Evidence example 1. Here you see I've cobbled together the 3 pictures. So on the left is the screenshot, on the right is the golden, and in the bottom there is a zoomed in portion of the differential. You'll see a little yellow diamond shape. Yeah, that diamond shape is a Unicode character with the replacement string that's supposed to be the replacement string in the input box. But looking at the golden, it should be an ellipsis, but it wasn't. Got that fixed right away. Fixed so fast, someone eventually spotted the mistake too, but by then it was too late. The correction was already getting ready to be built into the next test site. Evidence number 2. Check marks on were actually different sizes. Was this a mistake? Turns out, no. I was able to confirm with the designer that this was intended. A quick update to the goldens and we're back on track. Remember, not all changes are mistakes, and you'll need to update the goldens often enough to keep up with things. Evidence example number 3. This was a cute little find. Our footer changed ever so slightly, so it looks like 2 little snakes having a conversation. So this was an unintended change, very minor. It's invisible to the naked eye. No one would ever see it. No one ever complains. A few extra pixels. So again, updated the goldens, and the test was fixed. Example number 4. I had mentioned a lot of work went into our WCAG 2.1 compliant changes. So we darkened our fonts ever so slightly to meet contrast requirements, and the snapshot picked those up. So this was on the early stages of running Mark III. So it was just showing off its capabilities. I had a surprisingly large amount of goldens to update during this time, but this also allowed us to ensure that all the tool pages were actually getting updates. If we expect all of our pages to have a font change and only half of the goldens needed updating, then that's actually a smell that something might actually be wrong. You can see this Dave guy was impressed, and also this Josh guy as well. Following that, example number 5. So this was a unique catch. So we implemented a new component, which we will call subtle buttons, because they subtly look like buttons until you hover or focus it. Then a giant border pops up and actually looks like a button. Anyways, the icons were originally gray, and we updated it so that they all should be blue. All the unit tests that were run never caught this, like they never would. Only when it was implemented did I find the issue. So people are excited about this one. The cause? There was a fill attribute on the page that was overriding the new blue. So these tests can even sometimes discover things implemented incorrectly in specific situations. So this was the only subtle button within the whole application. Remember, 70 tools, multiple pages, the only one. Well, everything still worked. Somebody might find it, you want to keep things consistent. You want to make it look good. So this helped to keep our polish up on our software. All right, this was a tough one to see, but I'll give you all a moment to take a look at these 2 screenshots. Can you spot the differences? Give me time to get a drink. Functionally, it works. Translations work, it's accessible, it's responsive, but let me zoom in. If you look at the table, it's chunkier. That's it. This was a defect. We made our tables a bit bigger than they needed to be. But with such a large application, we don't have enough people to check every single different type of data input or a different type of page. And this would only be viewed if there was actually data in the table. So I lived with Mark III for a few months, and then a new set of issues became apparent. Not entirely with the tool, but with how and where I was running it. And here's what I discovered. Here's a few gotchas with running a visual diff solution. Working on a live site sucks. Live as in shared across the company. The site I pointed to was our newest QA sites whenever our continuous delivery would pump out a new one. I ran the test there against the last known good, but that means so did other automation. Our Selenium UI automation would change things on the site. Our manual testing would sometimes cause changes, which would be caught by the visual diff tests. I also discovered that updating the Goldens was super annoying. Deleting the old file, renaming new ones, moving them around, checking them into source control. There has to be a better way to handle that. Trying to switch between the 3 images, zooming in and out of different spots. So imagine just opening up Windows Picture Viewer and having the 3 windows, and then trying to like zoom in here and zoom in on this one and zoom in on all of them to figure out what was actually wrong, because sometimes they were just really small pixel changes. And then defects were occurring in areas that needed more page interactions to view, like errors in pop-ups or drop-downs. So I have my mantra, remember, load the page, take the screenshot, compare. I can't do that with these ones. I might actually have to break my rule. So what could a lonely senior test developer do? Well, I researched and I innovated. So here's how I handled these 4 problems. So problem number 1. As mentioned, working on a live site where other users are changing settings, making modifications is really challenging. I found a lot of other UI automation causing the real issues. So the way to work around this, spin up your own site. Like if no one else is using it, then you're good. Automating that's a little bit trickier. I haven't gotten to that point, but that's the dream. Encapsulate your data. See if you can segregate your screenshots to a part of the site that nobody else is using. I've tried that one the most. Apply a mask to your image. I'll talk about that shortly. And then the other one is DOM manipulations, and that one I'll also talk about in a second. So, image masking. A partial solution is if you're stuck using a live site, add an image mask. Before comparing, if you have a set area that constantly dynamically changes, block it off. It was super simple to implement, and updating a mask is as easy as opening up an image editing tool and blocking out some area. So take, for example, down here, my screenshot here. Every time you add an object, it gets added to the repository here. This is a picture repository tool. It would increase the count. If I'm taking a screenshot and somebody adds to the repository, the number goes up and my test fails. So I masked it. During the comparison, I would superimpose these black boxes over the numbers of both of these images. So I would essentially make them the same by adding the same mask over top of both of them. That way, tests can focus on the parts of the image that I really care about. Now you might think to yourself, wait, this doesn't seem good. Well, there is a word of caution to using this method. What's behind the mask might be something that you are worried about. So if there's a change that is behind the mask that is negatively impacting your site, you might not know about it. So use this one with caution. But the flip side to that is, what about this DOM manipulation I mentioned? Well, DOM manipulation, or DOM as in document object model, the code that represents a web page in your browser, it's what interprets it. Once your page is loaded, it's possible to just use JavaScript, make a call, and modify the DOM. Instead of masking the values, set them to be something static. By setting them, you're capable of maintaining better coverage of your page. Like, for example, you can still see that the font's correct. The big drawback is it requires adding more logic to the tests, which means more maintenance, and then you might have to keep track of page elements. And if anybody's done UI automation, you know that's, it's crummy. So in summary, for these 2 methods, masking is quick and simple, but you lose some coverage, while DOM manipulation is you maintain your full coverage, but there's extra code maintenance. So pick which one you want. So that was problem number 1 of 4. But what about problem 2 and 3? My goldens, my updating, my comparing. So all the image comparison and updating is strenuous. Like, the solution to this problem, though, that I came up with is I created a standalone tool that will take an image file and simplify the process. So I did that. I dubbed this application the Visual Diff Image Viewer. It was magical. The requirements for this tool, of course, these are what I decided I needed. So I needed to be able to view the image, all 3 of the images at the same time. So I needed the new screenshot, the golden that matches it, and then the diff. I needed it to update seamlessly, so the new images that I choose can replace the goldens without having to do all this rewriting and renaming. I needed it to zoom, pan, and keep all the images synchronized while I'm inspecting them. So if I zoom in on one, it has to zoom in on all 3 so that I can see the same area of the picture. I needed it to be quick, so I needed it to scroll through the pictures. So once I made my choice, it showed me the next one and I could quickly go through. And then I needed a reset button to put it back to normal after I did all my panning and zooming and moving and stuff. So even with a tool that can do all that, you still need human intervention to make judgment calls on your findings. Because your test won't know if a visual change was intended or not. So anyways, here's the solution I came up with. It's just a Windows app. My Visual Diff Image Viewer, it was born. Here's the screenshot. You can see 3 images all showing up at once with a myriad of buttons that perform actions all throughout it. But don't strain yourself at looking too close into it. I'll zoom in and I'll show you my very crude design. So I have a set of buttons between the 2 images for navigation and for image manipulation. Left arrow, right arrow, tells me what picture I'm currently looking at. I'm able to zoom in and out, and there's a reset button that says reset. For each of the main picture areas, you can see that I can set the path, so I can point it to whichever folder locally or on a network drive that my pictures are on. And then underneath I have these big buttons. This is where I make my choices. I can either A, keep the gold, where nothing happens, but then it removes this. I stop going back to this image if I'm cycling through because I already made my choice. Or I can take new, which will appropriately overwrite the correct file with my new image, so it has the proper name, and it gets it all set up for version control. I'm still doing that manually, the check-in, but that could also be automated, of course. So my synchronization between the areas, here's kind of an example of that. I've zoomed in on one area, and as you can see, they're all zoomed in on the same. I mean, this will work better if a live demo, but I'm not doing that. Live demos never work out. So, but if I do click on the image, if I click and drag in any of these 3 little windows, all of them will move at the same time. Same thing with zooming. Making this, while not pretty, very not pretty, took my comparing of images the old-fashioned way from about 10 to 50 minutes down to about 3. This, of course, barring any investigation into looking for serious issues that the test might have found. So there you go, 4 problems, 3 solutions. But what about my last problem? So going back to my list of challenges, I still had not ticked off the last one. It doesn't catch all visual issues without a lot of setup and performing page actions. So what was my solution? Well, I don't really have a solution for this one. Either I compromise and begin adding more and more page actions to hit elements deeper into the site, or I stick with hitting the URL accessible pages. I take what I can from there. Perhaps the next evolution of this tool might solve that. But while working on my Visual Diff tool, something amazing was happening at D2L. A visual diff movement was starting, and it was getting serious. So my approach was taking screenshots of the entire application, how it was built, and how it will look to clients. My other teammates, though, were looking into other ways of leveraging Visual Diff as well. Remember at the beginning of the presentation, I spoke about web component libraries, and I was going from Polymer and going to Lit and all this fun stuff. I didn't just bring that up to show that I was testing, but also to help showcase how developers were also starting to test. So with the move to Lit and seeing my work with Visual Diff, it got my team looking into doing this type of testing at the component level. You set a set of tests that would run on the components in their many different states before code merge, way before mine would do anything. It's super cool stuff, and I can tell you that all the inspiration was because of me. The tech stacks between my project and the component Visual Diff is unfortunately very different, so it's an entirely different solution. Theirs runs in Puppeteer for screenshots and uses a picture library called Pixel Match for diffing. It's run as part of their CI using Travis, mine uses Jenkins, along with the other unit tests. Lastly, their solution generates a nice report for quick viewing without the need of a separate tool. So they keep their goldens in GitHub along with the code, and everything needs to be checked in at the same time. So what do their reports look like? Here's an example of it. In the middle is the golden, and it, as you can see, it currently has round corners. This is one of those subtle buttons again. On the left is a check-in, and it has square corners. And then on the right, it shows the difference. So it's showing you that 241 pixels are different, highlights in red. Kind of goes back to my Mark I design, but it actually does a little bit better because it's more of a heat map than a jarring blood red. So if something like this happened, do you want to keep them round? Do they want to be square? No matter what the design, the human still makes the decision. And then you update the golden or you fix what's broken with it. So why was it decided to also do Visual Diff at the component level? Wouldn't mine be good enough? Well, in the world of web components, you could technically write a bunch of unit tests to cover the design. So there's this method called getComputedStyle, which would return like all the attributes of the component. So you get the height, the color, the margins, like everything you think about. And you could just match it with what's expected. To completely cover one component, you could probably write about 100 unit tests. Or how about just take one picture? Which would you rather do? Not to mention the cost of updating the test of the design changes versus taking a new screenshot. Now, of course, this has its downsides, like animations are tricky to capture. One way that we're actually looking to get around that right now is to increase the speed of the animation, so it just finishes animations real quick. And then, of course, this is technically slower. Rendering an HTML page is much slower than running a bunch of unit tests. But, asterisk, slower execution. If we went and full out and wrote thousands of unit tests instead of a handful of Visual Diff tests, then maybe the time would be negligible. Probably still be a second each. So it's worth it. So at the end, I had a good experience throughout the development of my solution. I think it left enough of an impact to show we should invest in a more robust solution, now that someone has experienced most of the shortcomings. It was definitely a learning experience and worth it to me, but I actually reinvented the wheel quite a bit, and some might think it's not worth their time. Truth is, there are actually some really good solutions out there, but I'm just stubborn, and I wasn't willing to compromise on my checklist. Some of the solutions I looked into and or found via Google search, DPXDT, Apply Tools, Galen, Percy.io, Chromatic, Diffie. Each have their own different issues though, which is why I built my own. Cost, where the images are hosted, browser compatibility. But there are also a lot of other free libraries written for other UI automation. Like I said, I used ImageMagick with Selenium, and of course you could use it with whatever, but I did find with a quick search that there are dedicated libraries for visual diffing with Test Cafe or Cypress. Now, last year I was fortunate enough to attend a great conference put on by the KWSQA called Targeting Quality. And during their presentation day, there was a talk called Automating Visual Testing and Health Checks in CI/CD. It was given by Radek Levming and Maciej Leskowski from Cognified. I actually looked up how to pronounce their names. Anyways, they created an open source tool called AET, and their presentation hit me right as I was preparing my internal talk. And their solution I found amazing. They've obviously spent way more time on this than I did, and they've really elegantly solved a lot of the challenges that I was having, and some that I haven't fully fixed yet on mine. So it was great to see that this type of testing is being done more broadly across the world. I'm not being paid to endorse them or anything, but AET is a free and open source software that anybody can download and set up. So if you have a few cycles and want to give it a try, I highly encourage it. So you can find it on their GitHub under Cognified/AET. And during their presentation, they're very enthusiastic about others giving it a try and are very receptive to feedback. So my final thoughts on visual diff testing. This type of testing has its pros and its cons. And even while I'm here championing it, I don't recommend it for everyone, at least not to start. Why did it work for me? Because the application I test is huge. It has a large surface area, so checking needs to be done at a whole bunch of places. Each nook and cranny has to be checked just to make sure I didn't break anything. UI automation can cover a lot of the functional portion, but it won't find breaks in the look and feel of a site. This tool checks all the dark spots faster than a human can. It's also really super handy to have screenshots of your application through time. It saved us a few times when a question arises is like, I don't remember that button being there. And be like, haha, January 1st, here's the picture, it's there. Saving the screenshots can save you a lot of time. Visual diff testing at the component level is good. It's more consistent. It keeps your application in better shape. So web components, your application is good, and visual diff testing closer to the code is good too. Building your own solution teaches you a lot, but do your research. I'd really consider heavily investing in a pre-built or open source product. But if you do go and build your own, look back on my journey and hopefully avoid some of the issues I ran into, or take into consideration in your design some of the things that you will run into. My implemented solution still has a lot of gaps. By no means is it perfect, but the journey of exploring visual diff testing is a lot like all types of testing. It has its goods and its bads, and this one definitely has its differences. Thanks everyone for coming out. I'm free to take any questions, and I will stop sharing so the Slido deck can pop up.
The sad thing about virtual meetings is you can't hear all the applause. I'm sure there is some. Oh, look at that. Clap reactions are coming up.
Okay, I'm going to just jump over to Slido for a second. Let's see if I can share my screen. This one. Here we go. So thanks everyone. Thanks Mark for the presentation. There are a few questions. We're going to, before we get into these questions though, I'm going to give everyone a chance just to ask questions that you might have had for Mark's presentation or questions about visual diff testing. If you go to slido.com or sli.do, our event code is 95190. I'm just going to put up a poll just so we can get some feedback on how would you rate today's meetings. So if you go to that event in Slido, it gives you a chance to provide that feedback to us, and just a way for us to know if this online format's working out for people. There is going to be a way to provide feedback to Mark as well after we ask our questions. So we'll just let that go for a minute or so, just give people a chance to get to Slido and access that information. Okay, so we'll leave that one running. What I'm going to do is see if I can get back to Q&A here. There we go. Mark, we're going to go in order. The Slido will order these by how many votes they have. So the first question that we have for you is, if you could do it again, would you still make a homegrown visual diff tool? What would you do differently?
If I could do it again, I don't think I would do it again because I've already done it once. It's kind of like building a car. As soon as you built your first car, you might not want to build a second one. You just go out into the lot and buy one. So I don't know. I'm stubborn when it comes to things, but if I were to do it again, definitely. Definitely. I see all my shortcomings. I probably would move off of my mantra and allow some deeper dives. One thing that I was toying around differently is maybe integrating our UI tests with the differential tests. So as the UI tests go through, take screenshots at each step and then compare as you go. That could really get deep dives, but that inflates the difficulty of UI tests, and there's a lot there. But something I thought about.
Cool. Thanks. The next question that we have, do any specific requirements come to mind that weren't covered by third-party visual diff products, or was a build over buy decision mostly a function of cost?
Ooh, a lot of it happened to be cost, but also how some of the third-party products did some of their things. So some of the solutions out there, the paid ones, is you pay per screenshot that they take. So you could have like 1,000 screenshots for X amount of dollars. Definitely my 750 screenshots every every hour on the hour. I did a calculation. It would cost me like 15 grand a month to run my way of doing it. I've probably changed the frequency and only run it on one build every so often. So that was just something. Some of them had the screenshots saved on their environment, so you couldn't actually keep them yourself. So like they had access to them, and I didn't want pictures of my company's application to be stored somewhere else like that. So it was a little bit of the hostingness of it, and the cost definitely did come in, but I think I could have figured out a way to make the cost work. But they're all pretty good. I mean, I've only watched a few demos and I've tried a few of the ones that I mentioned at the end. Most of them were just the name popped up when I searched. So their sales pitch looks good, but I wasn't convinced.
Yep. Thanks. The next question that we have is a short one. How long do you save your screenshots for?
So currently every single run I have, they overwrite the old screenshots. So I only save them whenever there's enough of a diff to save. So far I have screenshots that go all the way back since the beginning, but I try to purge them. I mean, this would be another thing to look at. You don't want to keep all your screenshots, but maybe it's good to keep a screenshot of the last build that you sent out to clients. So if they're on version 8 now, you might have one set from 7, 6, 5, 4, 3, 2, 1. So right now it says I hoard them a lot and then prune them when I think that I have too many.
Cool, thank you. The next question that we have is from Kevin. Are you currently, or do you foresee a need to version your golden screenshots in the future?
Good question. My screenshots, because I do check them into version control, I just happen to do it manually, so they do get put into GitHub as well. I do have versions of them. I'm not sure exactly how long those stay around. I'm not sure if I'm bloating it too much now that I think about it. So they are version controlled. I could go back and take a look at a screenshot from a while ago, the goldens that are checked in. So.
Cool, thank you. The next question is, with the wisdom of a hindsight, do you still believe that this development made sense? Wouldn't it be faster and cheaper to use commercial GUI automation tools? Similar to a question that we've asked before, so maybe if you just want a quick
It would have been definitely cheaper and faster. In hindsight, though, I think I got more out of it than I would have if I just used another application. So, I mean, at the same time of trying to get a solution out there, this was also kind of a learning opportunity.
Mhm.
Again, I'm going to go back to that crazy car analogy. It's like, yeah, I know what like a V8 engine is, or if that's even a thing, V6. I don't know. I'm not a car guy. I've already been corrected once on calling a 4-cylinder V4 by somebody. But you learn a lot by doing something from scratch, by making your own. So,
Mhm.
uh,
And you mentioned some very specific technologies for the application stack that the application that you're testing is built on. Is there anything that helps you with your custom solution for a custom app? Sorry, and just going off the rails for a second. If the app that you're testing is a custom application, is there something to be said for a custom automation testing solution that can directly talk to those technologies?
yes.
Yeah, thank you. So next question from Yuri. With a oh, sorry, that's a duplicate. We're gonna mark that one as answered. Second question from Kevin is opening your solution for public usage and contribution a consideration or a possibility?
I think it is. It's nothing super fancy, but definitely I could probably see it getting on one of our public GitHub repos, and I could probably open it up. Yeah, I mean, it's a little bit tailored specifically to run against our product, our LMS product. So there could be a little bit of refactoring I need to do to make it more open source friendly. But definitely, if I stop working on this one and want to go to one that's already pre-built or open source, I would definitely contribute to it because I find this stuff super interesting now.
Cool, thank you. Final question. Was there a consideration to have a default data set that completed all the field screens that is generally unchanged?
So yeah, that was kind of that could be a future implementation to it. What I did for my testing is that if I was testing a page that had a table, I would, again, this is back to the LMS world here. I could create like 4 courses, and then I would hit the same page on 4 different courses. And then I'd have this data set up specifically so that I'd hit an empty table, a full table, medium table, table with lots of icons. I could set up a plethora like that. It's nice because the sites that get built, they get built off of a template. So I add it to the template and I always have the data. But yeah, data generation was an idea. It would make things a little bit complicated, but we do have, I mean, internally we do have other projects that can be used to create more data. So it's a good idea. Like definitely just hitting the same page that doesn't change forever is not great. So like some tests don't make sense anymore. So like all tests, if they're always passing, they're not providing any value. So, you know, add some new data to it every once in a while, take different versions of the same page and see if that changes anything.
Neat. Thanks. Those are all the questions that I have. I'm just going to flip back to that last poll that we had up and running. Not that one, the other one. There we go. So thanks to everyone who voted for that. I'm glad to hear that generally people thought the meeting went well. I'm just going to quick jump over to the second poll that I created. We're going to leave this one up for a while afterwards. Just what feedback do you have for our presenter? This is a chance for us to gather feedback from Mark and just kind of help him know how his talk went. I'll leave this going for about half an hour after we close the Zoom meeting. So just feel free to go back and leave any feedback that you have for our presenter today. That's everything that I had for questions. Thanks, Mark, for answering them. I appreciate it. And I'll hand it back to Tina.
Cool. Thanks for facilitating Q&A, Kyle, and thanks, Mark, for a great presentation. And last but not least, thanks to all of you who came out today. It was great to see such a good turnout for our first ever virtual event. At this point, it seems likely that we might have another virtual event coming up, so hopefully we will be able to share more details about that soon. Yeah, as Kyle said, if you could take a few minutes to go provide some additional feedback for Mark, he would definitely appreciate it. So have a good rest of your afternoon. Thanks again.